Hi everyone, welcome back to our clean code series. In the last video, we looked at the basics of functions, like keeping them small and focused. Today, we are diving into chapter 3, part 2. We are going to cover more specific particular rules. Uh, we will talk about how to deal with switch statements, how to choose descriptive names, and how to manage function arguments. These rules will instantly make your code look clean and professional. Let's bring up the presentation. This section is a deep dive into switch statements, descriptive naming, and function arguments. These are the core building blocks of readable and maintainable code. By mastering these concepts, we can prevent code rot and make teamwork much easier. Let's start with a structure we see every day, but often write incorrectly the switch statement. The problem with switch statements. Switch statements are naturally hard to keep small. Even a simple switch with only two cases takes up to too much space for a single function. By their nature, switch statements always do n things at once. This means they clearly violate the single responsibility principle and the open close principle. Look at this code from listing 3.4. It grows every time a new employee type is added. But the worst problem is that this exact same switch structure will repeat in many other functions across the project, like is payday or delivery pay. This creates a lot of duplicated code. We can't always avoid switch statements, but we can hide them. The best solution is to bury the switch statements in the basement of an abstract factory and never let the rest of the system see it. The factory will use the switch statement only once to create polymorphic objects. Then all other operations like calculating pay or delivering pay are dispatched safely through the employee interface. This keeps your business logic clean, short, and protected from future changes. Use descriptive names. Next, let's talk about choosing names. It's hard to overestimate the true value of a good name. Remember Word's principle. You know you are working on clean code when each routine turns out to be pretty much what you expected. Choosing good names for small focused function is half the battle. Don't be afraid to make a name long. A long descriptive name is always better than a short confusing name. It's also much better than writing a long command. Use modern IDEs like IntelliJ to experiment with names until you find the best option. And finally, be consistent and use the same phrases and verbs across your models. Function arguments, the fewer the better. Now let's talk about function arguments. Arguments are hard because they take a lot of conceptual power to read and understand. The ideal number of arguments for any function is 0, which is called Niladic. 0 argument is perfect because it's trivial to test and understand. The best is one argument or monadic, followed closely by 2 arguments or dyadic. 3 arguments should be avoided where possible. More than 3 arguments requires very special justification and makes testing combinations extremely daunting. When you do use a single argument, remember that output arguments are very hard to understand We naturally expect information to go inside a function through arguments and come out through the return value. There are three acceptable monadic forms: asking a question about the argument, transforming it into something else, or handling an event. Avoid functions that use an output argument instead of a return value for a transformation. If a function transforms an input, the transformation should always appear as the return value. Flag arguments are ugly. The author writes very clearly flag arguments are ugly. Passing a boolean into a function is truly terrible practice. This loudly proclaims that your function does more than one thing. It does one thing if the flag is true, and another thing if the flag is false. A function called like render true is just plain confusing to a reader. The clear fix is to split the function into two separate well-named functions like render for suite and render for single test. Dyadic and triadic functions. A function with two arguments is naturally harder to understand than a monadic one. For example, right field name is simple, but right field output stream comma name requires a short pause to interpret. These two parameters have no natural ordering, which causes developers to accidentally swap them. Try to convert dyadics to monads by making the method a member of a past object. Functions with three arguments are significantly harder than dyadics. The issues of ordering and ignoring are more than doubled. So think very carefully before creating a try. Argument objects and variable arguments. When a function seems to need more than two or three arguments, it's a sign that some of them should be wrapped into a class of their own. Look at these two declarations. Make circle with coordinates x1, x and y versus passing a point center object. When variables are passed together like x and y, they are part of a concept that deserves its own name. This is not cheating, it's excellent software design. If you use variable arguments like in string.format, they count as a single list argument if they are treated identically. Verbs, keywords, and key takeaways. Choosing good names explain the intent of a function and the order of its argument. For a monad, the function and argument should form a clean verb-noun pair like right field name. You can also use the keyword form like assert expected equals actual to eliminate ordering confusion. Let's look at our key takeaways. Bury your switch statements inside an abstract factory. Spend real time choosing descriptive names. Minimize arguments down to 0 or 1 where possible. And never pass boolean flag arguments. That completes our deep dive into the first half of chapter 3. We now have a clear mindset for handling switch structures, picking descriptive names, and keeping our functions parameters minimal and clean. Applying these rules takes discipline, but it separates amateur code from professional craftsmanship. In our next video, we will finish chapter 3 by looking at side effects, command query separation, and error handling. Thank you so much for watching. Please hit that subscribe button, and as always, stay professional.